Good morning. We are Swen 10 presenting our design for web checkers. This presentation will cover different aspects of our design and how we chose it. Our design goal is to come as close to the MVP as we can. Our design has 3 tiers. Application, which contains all information required globally. UI, which contains visual information and navigation used separately by each user. And finally, our model, which contains all the data for the game, such as the board, which is the main model class. As previously stated, application tier design contains globally required information. This is information that is used by the UI tier, such as the routes. Our classes include board collection, game lobby, player lobby, and web server. Board collection interacts with boards, and player lobby interacts with players from the application tier. Board collection is a collection of different boards from each of the game lobbies. The game lobby is just a representation of each game that contains 2 players. And our player lobby contains all the players currently playing or signed into web checkers. Board collection interacts with moves from the UI tier. So you see here, board collection interacts with the different boards. It calls update on a board, and the board, you can put a board in a collection, you can get a board.
Now onto the UI tier design. This tier deals with the visual information of the checkers game and controls navigation between web pages. Within the UI tier design, there are 2 types of classes that are used in the project. These 2 classes are the get and post classes. The get classes work on rendering the web pages, while the post classes deal with requests, such as a button being pressed on the web page. UI tier also interacts with helper files, which are the fiddle files in the web checkers project. These files hold most of the visual information and interact with the UI tier classes to format and render web pages such as the sign-in page or game pages.
Our model tier design holds all data for the game. Everything is mainly stored in the board class, with a 2D square array as its field. And each square class has a piece field, which could be no. There are also move and position classes, which are primarily used for determining possible and validating moves. UI tier route classes also utilize these classes in their handle methods to determine the appropriate response.
This is the domain model representation of our project. To start off, the user, as seen in the top right of the slide, signs in as a player, selects a player to play against. Right now, the spectator or AI enhancements are currently not available and will be added in on the later stages of the project. From there, the 2 players play the checkers game, which is played on the checkers board, which has 8 rows. On the bottom of the screen, you can see that the checkers board has 64 squares, which consists of dark and light squares. On the bottom left, it can also be seen that there is 1 piece per square, which consists of kings and pawns. Now going back to the player domain entity, the players alternate turns, which consist of multiple jump moves, single jump moves, and simple moves.
At the end of the sprint, we had to update our state diagram to better reflect the new routes that we added to the UI. From before, we'll go through what initially happened. So once an HTTP connection was found, at the start of the state diagram, we went to the home, where a player would then sign in, and it would determine whether the post succeeded or failed once you get to that page. That depends on if they pass the checks for a valid username. After that, the user would get the game route and go into the game. Now on to the new stuff that we added. With the check turn route, in each game, each player will be constantly having a check turn, which checks to see if there's an active player's turn, and it goes towards validate move if your turn is the current turn. There, validate move calls posts that go back and forth and make sure that the move is valid. Once the move is valid and the piece is droppable, it goes towards the submit turn state, where a player is able to submit their turn and switch turns and go back to the basic game state. However, you also have the ability to call a backup move post, which allows you to revert your move before you submit it and make a different move that allows you to validate it. Once you've submitted, it'll then go back through a post to the submit turn URL and update the game view for both players.
In our Sprint 2, created a start a game sequence diagram. This is the overall entirety of the sequence diagram. However, in this presentation, we'll only be covering the processes. So the first half of it, up until the end of the lifelines in the condition of in-game, this section focuses on the processes, while the second half of it focuses on board view and getting the visual information with Template Engine running cohesively. So on the next slide, here's an up-close image of the sequence diagram where you can see the all the player processes that are important, and it covers the response object, session object, current player, opposing player, and the player lobby. And in the very beginning, you create an attribute with the session through the get game route, and you return the current player. And the following segments focus on getting an opposing player, and then once you get that player, you return the opposing player back to the get game route. Once the player is confirmed to be in lobby, and if they're in a game, you enter the, if they're in game, you have to exit out and then try again. Otherwise, if you're able to successfully enter the game, you are in the in-game condition until you are able to leave the game. And then you can leave the game using the attribute error message. And you are redirected back to the web server home URL once all of these conditions are met. Lastly, interesting design elements. One of the interesting design elements that our Sprint 2 had was the model class having a very good single responsibility with its separation of classes. For example, in the image, board and piece, position, row, space, and square are all very similar and they work well together. However, each of those have their own specific goal that they're trying to achieve in the code. For example, row represents a segment of squares, and there's obviously going to be like a king row, and that's actually also an interesting design element that will be covered in a second. So the separation of board and board view, where board view is the board that the players currently in the game view, while board is just all the data and information held by the board. And the separation of these is very important to the effectiveness of our implementation. As well as we have high cohesion amongst all of our classes, and specifically moves stem from simple move, where single jump move and multiple jump move are all based off of the simple move. Lastly, not creating a separate class for king piece or king movement, because king piece is represented by a Boolean variable. It helps us minimize the amount of classes we have to use, especially because it's such a simple condition that we can check for when we are updating the movement. Thank you for listening to our presentation of our Sprint 2 design.